Okay, hello. How's everybody doing today? I'm sorry that I can't be here on this exciting day when we learn the quadratic formula, but we will do some retracing of our steps on Monday, see how the quadratic formula is derived, and learn the song and sing together. So today you want to get out your notebooks and copy down what the formula is, and I'll work out a few examples. I would say you definitely want to include one or two examples in the notes. If you also want to just kind of watch one of the examples get worked out on the board, that would also be okay. So this is section 3.4. We're going to talk about the quadratic formula. Now, I'm not going to take the time to prove it while I'm not here because oftentimes when we do the proof of the quadratic formula, we have a lot of questions. So just know this. The quadratic formula is completing the square with all the steps rolled into a single formula. So when you are copying down this x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a, know that all of those a's, b's, and c's and the square root and the squared, that's all coming from completing the square. Now, you can use the quadratic formula as it says above the formula anytime you have an equation that looks like 0 equals ax squared plus bx plus c. So if you have something that's not in standard form, you wouldn't be able to identify your a, b, and c and use your quadratic formula. If your equation is not set equal to 0 before you begin, you have to make sure that it is. In the quadratic formula, you'll hear me say the opposite of b. I said that back when we did the vertex in standard form. I said opposite of b over 2a instead of negative b over 2a. Because if b happens to be a negative, then it will actually look like a positive number right there. So that's the opposite of what the b value is. Don't forget that you have to have plus or minus, so that should make sense to us knowing what we know about taking square roots. And then you have the b squared of the square root of b squared minus 4ac. And then this is all divided by 2a. Now, the easy way to remember the formula is our quadratic formula song. I will post a link on my website if you want to view it in advance and practice singing it. And we will also sing the quadratic formula song on Monday. So we'll have that song ready before we go into our test. The part that's underneath the radical here, the b squared minus 4ac, it has a special name. It's called the discriminant. So the discriminant is the part of the quadratic formula that shows up underneath the radical, or your square root. It looks like b squared minus 4ac. And based on the value of b squared minus 4ac, you can tell how many and what type of solution you will have. Okay. So we already kind of know what the options for how many and what type of solutions we can have. We can have two real, those show up as 2x-intercepts. We can have one real, where we have one x-intercept, the vertex of our parabola sits on the x-axis. Or we can have two non-real solutions or no real solutions, but these solutions we know to be imaginary. Okay, and that will look like a graph that doesn't cross the x-axis at all. So think about b squared minus 4ac. It's the stuff that sits underneath the square root. When you have a positive number underneath the square root, then you're going to have two solutions. Two real solutions. When the b squared minus 4ac, the thing underneath the square root, is equal to 0, then you're going to have one real solution. And something that we'll talk about later on when we get to polynomials is when you have that one real solution, like we could solve that one by factoring. It'll be like the two factors appear, the two factors are the same, so that one solution appears two times. So we say it has a multiplicity of 2. And then, of course, think about what kinds of numbers you would have under square root so that you would get imaginary solutions. Those will be negative numbers under the square root. So if your discriminant b squared minus 4ac is negative, you have two imaginary solutions. So if you want to know how many and what type of solutions you're going to have, all you need to do is b squared minus 4ac. If you find b squared minus 4ac, you can then find the solutions by plugging that underneath the radical. Now let's get to some examples. All right, let's list the number and the type of solutions. Okay, so we're going to start with negative 2x squared minus 3x plus 5 equals 0. So notice I don't need to know what the solutions actually are. I just need to know how many and what type I have. So I'm going to use my discriminant, which is b squared minus 4ac. A is always the coefficient to your x squared, so a is negative 2. B is always your coefficient to your x term, so in this case it will be negative 3. And c is always your constant, the term without an x, so we would say c equals 5. Plugging that in, I'll have negative 3 quantity squared plus 4 times negative 2 times 5. When I square the negative 3, it'll be a positive 9. And then I have positive 4 times negative 2. Oops, sorry, that should be a minus 4, shouldn't it? B squared minus 4ac, my apologies. B squared minus 4 times a, which is negative 2, times c, which is 5. Okay, so I'm going to backtrack. I always treat that 4 like a negative 4, so I say negative 4 times negative 2 is positive 8. And then positive 8 times 5 is positive 40. So that'll be 9 plus 40. So my discriminant is 49. That's a positive discriminant. Therefore, I have two real solutions. I'll do the next one. 2x squared minus 3x plus 7 equals 0. Okay. Again, if it would help you, you can label what your a's, b's, and c's are. So in this case, a is 2, b is negative 3, and c is 7. And let's see if I can do b squared minus 4ac correctly on the first go here. Negative 3 quantity squared minus 4 times 2 times 7. So I would say 9. And then it will be negative 4 times 2 is negative 8. Negative 8 times 7 is negative 56. 9 minus 56, that's going to be negative 47. And what's really important about that is that you have a negative discriminant, which means you have two imaginary solutions. So the only time you're going to have one real solution is if you repeat the b squared minus 4ac and you end up with 0. Okay, we're going to solve using the quadratic formula. So I've got my quadratic formula over in the opposite side. I'm going to go ahead and label, first I'll check my equation. It's equal to 0, so I'm good to go. I'm going to label my a value, what's in front of the x squared, it's 1. My b value is 4, and my c value is also 1. Note that I should never include the x's in the quadratic formula. I'm only including the coefficients. So I'm going to start my quadratic formula. X equals the opposite of b, which would be negative 4, plus or minus the square root of, and then I'm going to have a b squared, so 4 squared, minus 4 times a, which is 1, and c, which is 1. And then this is going to be an all over 2 times a. Notice that all over 2 times a, it extends over to that opposite of b. So don't just divide the radical by 2 times 1, but divide the whole thing by 2 times 1. Now, the next part that gets tricky for us is just following the order of operations. So when you're evaluating the quadratic formula, you are going to do the discriminant first. So I usually just kind of like write it above the square root. What's 4 squared? 16. And then negative 4 times 1 is negative 4. Times 1 again is negative 4. So now I write another line where I reduce. Negative 4 plus or minus the square root of 16 minus 4 is 12, all over 2. Now be careful right here. Some people kind of jump the gun and they might try to reduce the negative 4 over 2, or they might try to reduce 12 over 2. You can't reduce something that's under a radical with something that's not under a radical. And we can't reduce this negative 4 over 2 until we simplify our radical. So at this point, you have to make sure that your radical is simplified. So the square root of 12 is really the square root of 4 times 3. We've seen this one a couple of times in chapter 3 already. So that's negative 4 plus or minus. It'll be 2 square root 3 all over 2. And then you can now check to see if you can reduce, since negative 4, 2, and 2 are all outside of the radical, and they all share a common factor of 2, I can reduce each one by a factor of 2. So this will be negative 2 plus or minus, and then 2 over 2 will be 1, square root 3. I don't have to put over 1 because then it's just itself. So remember, think about how many and what type of solution you have. If you look back at your discriminant, which was 12, that's telling you have 2 real solutions. Are your solutions actually real? Yes, they are. There's no I here. And we have 2 solutions, negative 2 plus the square root of 3 and negative 2 minus the square root of 3. I'm okay with you writing one answer, okay, and leaving it as the exact form, unless you're answering a question about like what time something hits the ground. Then of course we probably want the answer that is a decimal. If you say negative 2 plus the square root of 3, we're not really sure how long that is. Actually, both of these, I do know the square root of 3 is approximately like 1.7. So negative 2 plus 1.7 would be negative 0.3. And then negative 2 minus 1.7 would be negative 3.7. So if I were to graph these as x-intercepts, both of my x-intercepts would actually be negative in this case. But that's okay. I'm really looking for the answer above in the first box, negative 2 plus or minus the square root of 3. Okay, let's do another example. And remember, you might want to include an extra example in your notebook, or maybe you want to kind of just follow along and make sure you're okay with all of where our numbers came from. Okay, so we're going to solve using the quadratic formula. We have 6 equals x squared minus x. Be real careful here. You can't identify a, b, and c until one side is equal to 0. So I'm going to go ahead and subtract 6 from both sides. So we have 0 equals x squared minus x minus 6. That means that a is equal to 1, b is equal to negative 1, and c is equal to negative 6. Okay, using my quadratic formula, x equals the opposite of b, so it's going to be a positive 1, plus or minus the square root of b squared, which would be negative 1 squared, minus 4 times a times c. So that's 1 and negative 6. And then all over 2 times 1. Work out what's underneath my radical. So I always do my discriminant first, the b squared minus 4ac. Negative 1 squared is 1, positive. And then I have a negative 4 times 1, which is negative 4. Negative 4 times negative 6, that's plus 24. So I can simplify this and say this is 1 plus or minus the square root of 25 all over 2. Again, in this example, I have 2 real solutions because my discriminant came out to be a positive. Remember, you always want to check your radical to see if you can simplify the radical. Well, the square root of 25, that's nice. We know that. That's 1 plus or minus 5 over 2. Now, for an answer like this, notice all the numbers became integers. They're all what we would call like nice numbers. So you should be able to simplify your answers further. I would break these up into 2. This is 1 plus 5 all over 2, and this one is 1 minus 5 all over 2. So that'll be 6 over 2, which is 3. And 1 minus 5 is negative 4 over 2, so negative 2. We had an example kind of similar to this one yesterday when we solved, or 2 days ago when we solved by completing the square. If you come out with these nice numbers like integers or fractions, if they're not irrational solutions, that meant that I could have factored to solve. So I sort of skipped over that check, but you really could look at an equation. So I'll go back up to the 0 equals x squared minus x minus 6 right here. Do you have factors of negative 6 that add to make negative 1? Yes, negative 3 and positive 2. So that if I FOIL that out, I get x squared plus 2x minus 3x, and then negative 3 times 2 is negative 6, so that's the same quadratic, x squared minus x equals 6. Set that equal to 0, and then I should set x plus 2 equal to 0, x minus 3 equal to 0, and my solutions are negative 2 and 3. But no, by solving by factoring, I did a lot less work. So it's worth your while always when you see something in standard form, I always kind of do this check. Can I factor it? Because if I factor it, I'll be doing less work. If I can't factor it, I would take my pick of completing the square or quadratic formula. If completing the square, if I had a leading coefficient other than 1 for the a value, if I had an odd number for my b value, I would definitely not choose completing the square and would move on to quadratic formula. In fact, in all reality, I'm usually always going to pick quadratic formula, but of course for your Chapter 3 tests, I may ask you to complete the square. Okay, and then I'm going to do one other example just to kind of show you one more before you get started on your homework. Solve using the quadratic formula. 5x minus 6 equals 3x squared. It doesn't matter which way you move, you should come up with the same answer. I generally still always try to keep my x squareds positive, so I'm going to go minus 5x plus 6. Move those two terms to the other side. Okay. A is equal to 3, B is equal to negative 5, C is equal to 6. Some of us don't have to do this step, and others of us will benefit from it. So if you need to list those things, do that. X equals the opposite of B, plus or minus the square root of B squared minus 4 times A times C, all over 2 times A. Do the discriminant, that's going to be 25. This is negative 4 times 3, that's negative 12. And negative 12 times 6 is minus 72. So I come up with 5 plus or minus the square root of, what would that be? Negative 47 all over 6. Since my discriminant was negative, I have two imaginary solutions. So remember, when you're showing imaginary solutions, you should always have an I in them. And the square root of 47 doesn't simplify, so I would leave it 5 plus or minus I, square root 47 all over 6. The 5, the 1i, and the 6, they don't share any common factors, so I'm not going to reduce them. And remember, you have to reduce all of them or none of them. So that would be my final answer, two imaginary solutions. Okay, your homework is page 127, numbers 5 through 11 odds. 19, 21, 23, 33, 34, 63, and 69. That's on your gold sheet. I would encourage you for all the odd problems to be checking your answers in the back of the book. if you have only one even problem on this homework assignment, but you could talk with your group members and see if you can't figure that out. I would really encourage you to not do all the calculations in your head, but rather show your setup. If all you have is an answer and your answer is wrong, I really can't help you decide where you went wrong. So kind of think about that and show your work step by step. Then I would encourage you to try this without so much calculator work, because then you can really pay attention to the signs. You do have to be careful when you type things into a calculator. Okay, and then I have a second quadratic formula song. I'll post that link online as well if you want to look at it and sing some songs. That would be totally fine with me if you came already prepared next Monday. But we will all sing together on Monday. Okay, thank you for listening. This video is posted online if you need to see it again. And I will see you on Monday.